Students, this is Sivakumar, 10th standard mathematics, chapter number 5, continuation of exercise 5.2. Now problem number 12. Let A of 3, minus 4, B of 9, minus 4, C of 5, minus 7 and D of 7, minus 7 show that ABCD is a trapezium. Here is question number 12. For proving ABCD is a trapezium, it is enough to prove two opposite parallel sides and two opposite non-parallel sides. For that, you have to find out the slope of AB, BC, CD and DA. Can find one by one. Slope of AB. Formula y2 minus y1 divided by x2 minus x1. A and B. A that is 3 minus 4, B 9 minus 4, x1, y1, x2, y2. Substitute y2 minus y1. y2 that is minus 4. Minus here also minus. So minus into minus plus 4 divided by x2 minus x1. 9 minus 3. Minus 4 plus 4 that is equal to 0, 0 by 6. 0 by anything is always 0. That is slope of AB. Now slope of BC. Same formula. So write the points B and C. B that is 9 minus 4 it is given, and C 5 minus 7. So consider them as x1 y1, x2 y2. Formula same formula, y2 minus y1. y2 that is minus 7. Formula minus y1 that is minus 4. Minus into minus plus 4 divided by x2 minus x1 that is 5 minus 9 equals minus 7 plus 4 that is equal to minus 3 divided by 5 minus 9 that is minus 4. Minus minus get cancelled, 3 by 4. Now slope of CD. Slope of CD same formula. Write the point C and D here. C and D. C that is given 5 minus 7. D point is 7 minus 7. Consider them as x1 y1, x2 y2. y2 minus 7 minus of y1 that is also minus 7, minus into minus plus 7 divided by x2 minus x1 that is 7 minus 5. Minus 7 plus 7 that is equal to 0. 7 minus 5 that is equal to 2. 0 by 2 that is equal to 0. Finally, slope of AD. Slope of AD. Write the points A and D here. A that is 3 minus 4, D 7 minus 7, x1 y1, x2 y2. y2 that is minus 7. Formula minus. Here minus 4 minus into minus plus 4 divided by x2 minus x1. 7 minus 3. Minus 7 plus 4 that is equal to minus 3. 7 minus 3 that is plus 4. 7 minus 3 that is 4. Minus 3 by 4. Look at that. Now here slope of AB that is equal to 0. Slope of AB that is equal to 0. And slope of CD also 0. Since slope of AB and slope of CD are equal, AB is parallel to CD. At the same time, slope of BC that is equal to 3 by 4. But slope of AD that is minus 3 by 4. They are not equal. Therefore, BC is not parallel to AD. So, two parallel opposite sides and two parallel non-parallel opposite sides. Therefore, ABCD is a trapezium. Now, we can write the result. Since slope of AB that is equal to slope of CD. Slopes equal means the two lines are parallel, that is AB is parallel, it's a symbol for parallel to CD. Let it be number 1. And since slope of BC is not equal to slope of AD, which implies BC is not parallel to AD. Here the two lines are parallel, here the two lines are not parallel. From 1 and 2, ABCD is a trapezium. I draw the diagram over here for your reference. A, B, C, D. Here AB and CD are parallel and AD and BC are non-parallel. Therefore, ABCD is a trapezium. Problem number 12 is completed. I will be teaching problem number 13 in the next video. Thank you, children. Hi students, this is Sivakumar. 10th Standard Mathematics, chapter number 5, continuation of exercise 5.2. Now problem number 13. A quadrilateral has vertices at -4, -2, 5, -1, 6, 5 and -7, 6. Show that the midpoints of its sides form a parallelogram. Show that the midpoints of its sides form a parallelogram. Okay. Here you are given A, B, C, D, that is a quadrilateral. We have to prove midpoints of all the sides form a parallelogram. First we can find the midpoints of each and every side. P is the midpoint of AD. Midpoint of AD equals midpoint formula x1 plus x2 by 2 comma y1 plus y2 by 2. I write the points A and D here. A that is equal to -4 -2 and D -7 comma 6. This is x1 y1 x2 y2. x1 plus x2 -4 -7 divided by 2, y1 plus y2 -2 plus 6. That is equal to -4 -7 is -11 divided by 2, -2 plus 6, that is equal to 4 by 2. You can cancel 2 times. That is equal to -11 by 2 comma 2. Point P over. Now Q. Q is the midpoint of AB. Q, that is the midpoint of AB. Points A and B equals A that is -4 -2, B that is 5 comma -1 equals same midpoint formula -4 plus 5. This is x1 y1 x2 y2. x1 plus x2 by 2. So -4 plus 5 by 2. y1 plus y2 -2 -1 equals -4 plus 5, that is equal to 1 by 2 comma -2 -1, that is equal to -3 by 2. Now R equals R is the midpoint of BC. BC. So R is equal to midpoint of BC. Equals B and C points I write over here. B that is 5 comma -1, C that is 6 comma 5. This is x1 y1 x2 y2. Midpoint formula, you know that x1 plus x2 by 2, 5 plus 6 by 2 comma -1 plus 5 by 2, -1 plus 5 by 2. 5 plus 6, that is equal to 11 by 2. This is -1 plus 5, 4 by 2. 11 by 2, 4 by 2. That is equal to 11 by 2 comma 4 by 2. You can simplify by 2 table 2 times, that is equal to 11 by 2 comma 2. Finally point S. Look at the diagram. S is the midpoint of CD. Midpoint of CD. C and D. C point is 6 comma 5, D point minus 7 comma 6. Consider as x1 y1 and x2 y2. Formula x1 plus x2 by 2, 6 minus 7 by 2, 5 plus 6 by 2. y1 plus y2 by 2, that is 5 plus 6 by 2. 6 minus 7, that is minus 1 by 2. 5 plus 6, that is 11 by 2. Now I got the points P, Q, R and S. All the 4 points. Now for proving that PQRS is parallelogram, it is enough to prove midpoint of the diagonals are equal. That is, midpoint of PR equals midpoint of QS. If it is, PQRS is a parallelogram. So first we can find the midpoint of PR. Midpoint of PR equals midpoint formula. You know that x1 plus x2 by 2 comma y1 plus y2 by 2. Same formula only. I write the points P and R only. P and R. P point we got it already, minus 11 by 2 comma 2. R point, here it is 11 by 2 comma 2. 11 by 2 comma 2. This is x1 y1 x2 y2. x1 plus x2 by 2, that is minus 11 by 2 plus 11 by 2 divided by 2, because x1 plus x2 by 2 comma y1 plus y2 by 2, that is 2 plus 2 divided by 2. Plus 11 by 2 minus 11 by 2 both get cancelled. What is the numerator? 0, 0 by 2. 2 plus 2, 4 by 2. 0 by 2, that is equal to 0. 4 by 2, that is 2 only. So 0 comma 2, that is midpoint of PR. Now another diagonal QS. We have to find out the midpoint of the diagonal QS. Midpoint of the diagonal QS. Even here I include the word the diagonal. Midpoint of the diagonal PR and midpoint of the diagonal, sorry, here QS, not QR, QS. QS equals, I write the points Q and S here. Q here it is 1 by 2 minus 3 by 2. 1 by 2 minus 3 by 2. Next, S point. S, that is equal to minus 1 by 2 comma 11 by 2. Here it is minus 1 by 2 comma 11 by 2. Equals now this is x1 y1 x2 y2. x1 plus x2 by 2, half minus half by 2 comma y1 plus y2 by 2. See, x1 plus x2 by 2, half minus half by 2, y1 plus y2 by 2, minus 3 by 2 plus 11 by 2 divided by 2 equals, half minus half get cancelled, 0 by 2. Here 2 is the LC common denominator, add the numerator minus 3 plus 11 divided by 2 equals, 0 by 2 is 0, 11 minus 3, that is 8, 8 by 2 by 2. 0 comma 8 by 2, that is 4, 4 by 2. 4 by 2, that is equal to 2. 0 comma 2. That is equal to 0 comma 2. See, look at that. Midpoint of PR, that is equal to 0 comma 2. Midpoint of the diagonal QS also 0 comma 2. So outright the result, since final result, since the midpoint of diagonal PR equals midpoint of the diagonal QS, P, Q or S form a parallelogram. So problem number 13 is completed. Hi students, this is Sivakumar, 10th standard mathematics, chapter number 5, continuation of exercise 5.2, problem number 14. PQRS is a rhombus. Its diagonals PR and QS intersect at the point M and satisfy the condition QS, that is equal to 2PR. If the coordinates of S and M are 1, 1 and 2, -1 respectively, find the coordinates of P. Okay. Here is question number 14. PQR is a rhombus given. First we can draw the diagram. Rhombus. Here you are given QS, that is equal to double PR. So QS is greater in length. So here Q, here S. So, right? So P, Q or S. Otherwise you take Q, S over here. P, Q, R, S. Which one is greater in length? QS. QS, that is equal to double PR. So you have to draw the diagram like this. Okay. It is a rhombus. QS is greater in length according to the problem. QS, that is equal to double PR. So PR is shorter in length. Here two diagonals QS and PR intersect at M. That is given in the question itself. Here M is the midpoint of the diagonals. That means PM and M are equal. SM and MQ are equal. These two are equal. These two are equal. The diagonals in rhombus, the diagonal bisect each other and cut at right angles. Each and every angle is 90 degree. 90, 90, 90. Okay. You are given the points S and M. S and M are given. S, that is 1, 1. Right, 1, 1 here, and M, that is 2, -1. 2, -1. You are asked to find out the point P. I consider the point P as X, Y. You have to find out X, Y. How to find? So in this diagram, SM and PM are perpendicular. If the two lines are perpendicular, we know very well, product of their slopes equals -1. You can apply the formula, slope formula, y2 minus y1 divided by x2 minus x1. Here PM is perpendicular to SM. PM is perpendicular to SM. Therefore, slope of PM into slope of SM, that is equal to -1. This is a formula. The two lines are perpendicular, product of their slopes equals -1. Now we can apply the formula, slope formula Pm. Write the points here, P and M. P that is x comma y, M that is 2 comma minus 1. Okay. Consider as x1 y1 x2 y2. Substitute in the formula here it is y2 minus y1 minus 1 minus y minus 1 minus y divided by x2 minus x1 2 minus x. Now Sm, slope of Sm, S and M. S that is S and M. S 1 comma 1, M that is 2 comma minus 1. Consider as x1 y1 x2 y2. Formula y2 minus y1 minus 1 minus 1 divided by x2 minus x1 2 minus 1, that is equal to minus 1. Minus 1 minus y divided by 2 minus x into minus 1 minus 1, that is equal to minus 2 divided by 1, that is equal to minus 1. Okay. Now multiply minus 1 into minus 2, that is equal to 2, minus y into minus 2, that is equal to 2y, divided by 2 minus x into 1, that is equal to 2 minus x, that is equal to minus 1. 2 plus 2y, that is equal to cross multiply minus 1 into 2 minus x, just cross multiply. 2 plus 2y, that is equal to minus 1 into 2 minus 2, minus into minus plus x, minus 2 plus x. Okay, plus x comes left hand side, minus x, already we have 2y in the left hand side, minus 2 constant, let it be in the right hand side, plus 2 comes right hand side, minus 2. So minus x plus 2y, that is equal to minus 4. Well, let it be equation number 1. Given Qs, that is equal to 2PR, that is given, which implies 2, when it comes to the left hand side, it becomes half, reciprocal. Half Qs, that is equal to PR, which implies half Qs. Look at the diagram. Qs, half of Qs is Sm, correct? Because M is the midpoint. Qs, half of that is Sm. So half Qs can be replaced by Sm. And PR, that is equal to double Pm, because M is the midpoint. Pm, Mr and Pm are equal, therefore Pm plus Pm double Pm. So PR, that is equal to 2 Pm. 2 Pm. Right? Now we can apply the distance formula. I write the distance formula here. Distance, that is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. S and M. S and M. S point, that is 1 comma 1, M 2 comma minus 1. 1 comma 1, 2 comma minus 1, x1, y1, x2, y2. Yes, distance formula here it is. Square root of x2 minus x1, 2 minus 1, the whole square, plus y2 minus y1, minus 1, minus 1, minus 1, minus 1, the whole square. That is equal to 2 into root of Pm. Write the points P and M. P, that is x comma y, we have taken x comma y. M, that is 2 comma minus 1, this is x1, y1, x2, y2. Substitute in the same formula, x2 minus x1. x2 minus x1 is 2 minus x. 2 minus x the whole square plus y2 minus y1. Minus 1 minus y. Minus 1 minus y the whole square. Squaring on both sides for eliminating the square root. On squaring. While squaring, the square root will be eliminated. You will be getting only 2 minus 1 the whole square. 2 minus 1 is 1, 1 square. minus 1 is minus 2 the whole square. That is equal to, while squaring 2 becomes 2 square is 4. Then while squaring, square root will be eliminated. You will be getting 2 minus x the whole square plus minus 1 minus y. You take minus as common, minus of 1 plus y the whole square. Minus 1 minus y, I have taken minus common, minus of 1 plus y the whole square. The next step, 1 squared is 1, minus 2 whole square is 4, that is equal to 4 into 2 minus x the whole square plus, while squaring, minus square becomes plus, so only 1 plus y the whole square. What about that minus? Minus square means minus into minus is plus only. Now 1 plus 4, that is equal to 5, that is equal to 4 into, here you can apply a minus b whole square formula, a square plus b square minus 2ab, which one is a? 2b, that is x. Plus, here you can apply a plus b whole square formula, a plus b whole square is a square, that is 1 square, b square, that is y square, plus 2ab, 2 into 1 into y. Close the bracket. So 5, that is equal to 4 into 2 squared is 4, x squared as it is, minus 2 into 2, 4x, plus 1 squared is 1, plus y squared, plus 2 into 1 into y, 2y. 5, that is equal to 4 4s are 16, plus 4 into x squared, 4x squared, 4 into minus 4, minus 16x, 4 1s are 4, plus 4 into y squared, 4y squared, plus 4 into 2y, that is 8y. Which implies, keep all the constants the left hand side, 5 plus 16 comes left hand side, minus 16 plus 4 comes left hand side, minus 4. That is equal to 4x square, then 4y square, then minus 16x plus 8y. Right? 5 minus 16, that is equal to minus 11, minus 11 minus 4, that is minus 15. So which implies, write that 4x square plus 4y square minus 16 plus 8y, that is equal to minus 15. I have written RHS and LHS, LHS and RHS, no change of sign. Write as it is. So what's the value here? Minus 15, I have written here, minus 15. Okay. We have two variables, x as well as y. One variable to be eliminated. For that, in equation number 1, from equation number 1, I find x first. Here we have equation number 1. Okay. Here 2y minus 4 comes left hand side plus 4. This minus 6 comes right hand side plus 6. I consider this is equation number 1. Which one is equation number 1? X, that is equal to 2y plus 4. I highlight that one. This x value can be replaced in that final equation. X, that is 2y plus 4, remember. And let it be number 2. Equation number 2 implies 4 into x can be replaced by 2y plus 4 the whole square plus 4 into y squared minus 16 into x. What is x? X, that is equal to 2y plus 4 plus 8y, that is equal to minus 15. This x value is taken from which equation? First equation. Okay. Now you can expand. 4 into, here you can apply a plus b whole square formula. First write 4, then a plus b whole square formula. 4 into a squared plus b squared plus 2ab. Which one is a? A, that is 2y, b, that is 4. 2y and 4. Here 2y, 4, 2y, 4. Next, 4y square as it is. 4y square as it is. Next, minus 16 into 2y minus 32y minus 16 into 4 minus 64. Minus 32y minus 64. plus 8y minus 15 comes left hand side plus 15, 8y plus 15 that is equal to 0. (8y plus 15 that is equal to 0. Now we can solve this equation. Before that we have to simplify. 4 into 2y the whole square is 4y square. 2 square is 4, y power 2 is y square. 4 square is 16 plus 2 2s are 4, 4 4s are 16, 16y, close the bracket, plus 4y square minus 32y minus 64 plus 8y plus 15 that is equal to 0. 4 4s are 16y square, 4 into 16 64, 4 into 16 64y, again 4y square minus 32y minus 64 plus 8y plus 15 that is equal to 0. Now 16y square minus 4y square together 20y square. Then y term 64y minus 32y that is equal to 32y. 32y plus 8y that is equal to 40y. Finally the constant plus 64 minus 64 get cancelled. So only 15 left out, plus 15 is equal to 0. Before solving this equation, we can divide 20, 40 and 15. Each and every one can be divided by 5. Divide by 5. 20 by 5 that is equal to 4, 4y square. 40 by 5 that is equal to 8, 8y. 15 by 5 that is equal to 3 that is equal to 0. Now we can factorize. The coefficient of y squared is 4. 4 3s are 12. And coefficient of y that is equal to 8. Product 12, sum 8, the two numbers are 6 and 2. 6 plus 2 8, 6 2s are 12. Since it is an equation, you can find the values of y directly. The coefficient of y square, what is here? 4. Change the sign. Plus 4 becomes minus 4. Write minus 4 in the denominator. And simplify. 2 table 2 times, 3 times, 2 table 1 time, 2 times. 3 divided by minus 2, that is minus 3 by 2. 1 divided by minus 2, that is minus 1 by 2. You got the values of y. Now substitute the values of y in equation number 1 to find the values of x. First I take y that is equal to minus 3 by 2. When y that is equal to minus 3 by 2, equation number 1 implies, in equation number 1 we have x that is equal to 2y plus 4. 2y plus 4. X that is equal to 2y plus 4. Y value minus 3 by 2. 2 to get cancelled. X that is equal to minus 3 plus 4. Minus 3 plus 4 that is equal to 1. Okay. Next, when y that is equal to minus 1 by 2. Next value of y is minus 1 by 2. Same equation. Equation number 1 implies x that is equal to 2y plus 4. 2y plus 4. Y value that is minus 1 by 2. 2 to get cancelled. X that is equal to minus 1 plus 4. Therefore, x that is equal to minus 1 plus 4 is 3. Therefore, two answers for P. We consider P as x comma y. Therefore, P equals, write the result here. Therefore, P equals, for x value 1, y value minus 3 by 2. 1 comma minus 3 by 2. This is one answer. 1 comma minus 3 by 2. Or x value 3, y value minus 1 by 2. X value 3, y value minus 1 by 2. 3 comma minus 1 by 2. 3 comma minus 1 by 2. Okay. Now problem number 14 is completed. I'll be teaching problem number, this exercise is over. I'll be teaching the next exercise in the next video. Thank you, children.